Of course, here's the OWASP Web Scarab, web application testing, which can be used as well, and it does a really good job on getting you the information that you need about the website. Pretty sweet little tool. And of course, there is even a Linux distro available specifically designed for web application testing, and it is called Samurai. And you would basically use this because it has all the pre-tools, I guess, for specific on your web application thing that you can do that will allow you to, focus specifically on those types of testings and so forth. So it's pretty cool. Again, it's called Samurai. Okay, let's revert a little bit and let's talk about some of the SQL injection stuff and what happens here when it comes to injecting into the database and looking at what's actually happening there. And things like that. All right, so let's take a peek into that and see what we can get going there. So when it comes down to SQL injection and so forth, there's a slight difference between the two. There's what's called indirect attacks, which are attacks against the database itself. This would be done through SQL injection. We could also check for weak passwords, and data manipulation can also take place at this level. Then we have the direct attacks, and this would be against the server itself. Now the direct attacks will either be done through buffer overflows, would be done through weak passwords, as in checking for weak passwords, vulnerable services left running on the system, and any kind of platform vulnerability with underlying OS as well. So again, remember we talked about protecting in layers, right? The whole defense in depth scenario. So we need to make sure that we protect in those different layers, whether it be the OS, whether it be the applications that are running on the OS or whatnot. And those are definitely some of the things we need to take a peek into and allow for that as we go out there and use either some of the tools and so forth with that. Okay, so when it comes down to injection flaws, right, this was number 1 on the OWASP list that we already discussed. Right, so one of the most common attacks on database application is SQL injection. This is where malicious code is entered into the field to make system execute a command shell or other code. It can also be used to bypass authorization, retrieve unauthorized data, and alter data on the database systems themselves. An example here of the code used in web application would be something like your username equals John Doe and the password equals anonymous. So what would happen if we inputted the data itself were a single quote? I mentioned this before, right? What happens is that we can tell that it's vulnerable to SQL injection, especially if it gets this error message. So the Microsoft OLE DB provider for ODBC drivers, error 80040E14. This could indicate that we have a server that is vulnerable to SQL injection attacks. Impacts here for SQL injection is that the access to the entire database schema can be reached. We can steal, modify, and delete database components even. We can prevent legitimate access to the database. It's causing some type of denial of service there. We can run the operating system commands, in this case, on a database server. We can also disclose company proprietary data as well, so we need to keep that in mind as we're going out there and doing these types of attacks. So here's what that would sort of look like, right? So we basically have a SQL statement within the form field. So here we have something like select name, phone, address, bank details, and so forth from table logins, where the name equals this and the password equals that. Right, the white boxes in this case refer to the user input fields on the database front. And keep in mind here that it's actually containing a variable containing some type of value. So it would be like a var name and var password and so forth. The data you enter into the user input field is then being used to build the complete SQL statement, but an attacker may not enter the username and password. What they could do is put in something like a single quote or 1 = 1 semicolon dash dash to bypass the login authorization. So some of that, let's break that down and see what that would look like. So here, with the if we put in the single quote, this basically closes the user input variable. We then continue the SQL statement with the OR statement. Then we give it a true statement, in this case 1 = 1, which is a true statement. We finish the statement by using a semicolon. Then we comment out the rest of the line so it doesn't get processed. So in this case, the password never even gets looked at. So with this, when we put this in there, we can actually then log in as the first record in the account on the database. Pretty sweet, right? Again, the server needs to be vulnerable to this type of attack for us to be able to do this successfully. So don't try this out on any of the servers out there on the internet. or your own, unless you have, of course, explicit permission to do so. And when it comes down to looking at some different SQL components, I would say make sure you have a good idea of this right here. Single quote is definitely going to be important. Your or 1 equals 1, of course, your dash dash, or your commenting out of your rest of the lines that was done there. Now, one thing I want to mention here too is when it comes to the SQL injection side of enumeration, here we can actually use different things to get into. So here we're actually using a union all select statement and so forth. Here, if we pop in this, as you notice here, we're getting information back, but we're running it from the local host. So this is actually on the machine that we're currently on, but you would basically put in the IP address or the scenario of the web server, or the IP address of the web server, and so forth, and we would put in specific information to grab whatever columns and rows that we have, that we're noticing in the database. Now, we generally would get this through error messages and so forth. So the use of verbose error messages will actually assist us in putting in additional SQL queries and so forth, right? So by using the having SQL command for this particular instance, an attacker can generate errors from any record set, and again, this will then give us additional record set that we can then use, and then of course we go from there one to the other to figure out, you know, what is actually going on, what current rows and columns we have in that database, and then of course from that we can then maneuver on to the next statement that we want to do and so forth. Because as you can see here, it says, hey, the FBC user's ID is invalid because it doesn't contain an accurate function where, and there's no group by clause. So then you put another one in with using the group by and so forth. Now, you don't need to know all that specifics in regards to when it comes to the exam taking, but you do want to get some basic ideas on you know, SQL injection and so forth. So whenever you see any type of SQL comments, SQL language in the code itself, then just know that it most likely has to do with SQL injection itself. Now, there is another term I want to mention here, is using blind SQL injection. And blind SQL injection is basically the same thing as regular SQL injection. However, what happens with blind SQL injection is there's no results of the injection visible to the attacker. So if we put in the quote, single quote, having 1 equals 1, semicolon, dash, dash, and it does not come back with an error message, and then we basically go off of the timing, as in, does it come back right away with nothing, or does it delay for a few seconds? That can then be the indicator of how to pursue further. But I would recommend that you be a database administrator for those types of things, or at least get yourself some tools that will allow you to do some of that as well. But that's called blind SQL injection, which is basically, as I mentioned, the ability to do a SQL injection, but not relying upon the error messages, because you won't get any and such. So keep that in mind as you're out there trying maybe some of these out and so forth. But the questions that you may get on that are going to be pretty straightforward. So you should be able to identify different types of SQL injection attacks. Again, mainly looking at the SQL injection, as in the SQL queries and so forth from that. And you should be able to identify those types of things. So if you come across coding that has to do with that, just make sure that you look at things such as, and keep in mind, it may not be always in ASCII format, so you may see it in Unicode format and so forth. But a lot of times you're going to have things like, update, user table, and things like that within that as well. And again, those are generally identifiers of SQL injection, having the or 1 equals 1, the single quote, the having clause and so forth as well to assist with that process. Now, we also have what's called extended store procedures, which are also very nice because this allows us to perform powerful actions, including communication with the operating system itself. Let's see, there are several extended store procedures that can cause permanent damage to the system. So to inject and execute an extended store procedure, use any input method. We can put a URL submission in there. So again, here we're using, for instance, web page ASP, question mark, city equals Edinburgh, and then we put in the exec masterdbo.xp underscore command shell IIS reset, and what this will do is basically pass like a denial service to the operating system. Keep in mind that the SQL Server by default generally runs under an admin level service account called the SA account with a blank password. If you want to perform, some of these advanced injection attacks against vulnerable websites, and you're not able to do that with a command shell hack, you must, of course, make sure that the XP underscore command shell is enabled on the SQL Server to launch those types of attacks. Right? So that XP underscore command shell is definitely going to be an important one that you need to remember as well when it comes down to some of the SQL injection stuff and such. Here we see another looking at the SP underscore make web task, and what this will allow us to do is actually create a web page, and according to what we have here, we're actually grabbing the name password from the master DBO sysx logins, which basically gives us the information back, in this case, of our users with their encrypted passwords. And then basically we would use these hashed passwords and pop those into a SQL password cracker. We simply do this by using a shutdown with no wait, and then of course what this will do is immediately stop the Windows service. All right, so we can do the select username from where username equals shutdown with no wait in the password zone, but keep in mind the -- won't even process that. But needless to say, that will assist in that whole process. Again, we're providing some type of denial service against the server itself, and then with that are able to actually go in and do so. As we mentioned with the direct attacks, another scenario, right? These exploit the database server rather than the database application. Direct attacks could also include any attacks that exploit the underlying OS where the database server is installed on. We have buffer overflows and heap overflows and weak SQL login passwords that are all examples of direct attack vulnerabilities. The upcoming slides here show a series of tools that we can use at our disposal that will attempt to take advantage of those weaknesses. So we have the SQL connection properties. And here we have, for instance, let's see, here we're mentioning the connection to the database, which has properties assigned to it. This includes the web front end, and the page has to authenticate. And it generally has a username and password. Now, if you see the SA account in there, as we see highlighted, that means that it's using the default, most likely the default username and password for that. So SA, again, uses the default password of nothing, as in blank. When it comes to attacking the database servers, here, important to know what ports are open. And specifically here on this page, the important ports that you need to remember are ports 1433 and 1434. Now there are other ports here that we're mentioning. These are great FYI, like your 1521 for Oracle, 3306 for MySQL, and 5000 for Sybase, 1498 for SQL Anywhere. We can connect to those different servers various ways, such as you see here with our MS SQL Server. We can use the osql.exe with a -e if we're using a trusted connection, or we can use the osql.exe with a -s, put in basically the source, and then we're given it a username and a password. Oracle SQL Plus, use the username /password @db, and then of course here the SQL, you do MySQL with the -h, put in the host name, then you put in your username and your password to gain access. All right, we can also obtain sensitive information. So if you have a database connection where you can submit SQL queries directly to the server, you can attempt to retrieve sensitive information there. So for instance, as we saw before in the screenshot, we can select the names and the password from the master DBO sysx logins, which again allows us to grab a hold of those SQL hashed passwords. Of course, we can do the same from Oracle and MySQL using the from sysdb_users or the masters.dbo sys logins for MySQL. Of course, some of the tools we were going to mention here is Kane Enable that you can use for that. It does a pretty good job. Oracle pwguess if you're using Oracle, and SQL BF is something you can use on the SQL side as well. And these are just some of the more common password crackers for database servers. Of course, Google search for a list of additional ones out there, but keep in mind that it all comes down to just knowing where to find some of those resources. A lot of times a Google search or whatnot could assist you in that whole process. Here's another tool called SQL Scan. And it's a server discovery tool, and by default only scans on UDP port 1434. It can also force TCP ports 1433. And this is also one of many great tools from Foundstone, as in another one we talked about earlier, which was called SuperScan, is also another great one that you could utilize from that as well. OSQL. If you have valid credentials on the SQL Server, you can also log on with direct access tools such as your OSQL exe tool. This tool allows you to execute arbitrary SQL commands against the server itself. If your database is set up for trusted connections, you may also have luck in exploiting the operating system also. Here we have a trusted connection from the OS, and it has given us access to the master sysx logins table. This has allowed us to retrieve the password hash from the SA account. Pass that hash then to a SQL password cracker, and voila, you get yourself a nice password for that user. And we also have other tools that we can use that will exploit all this fun stuff too, and it's called Metasploit. And it has a number of exploits already ready to attack Oracle or SQL servers, and all are either buffer or heap overflows will also gain immediate access if you're using that through that. For the exam, you will not need to know any of the Metasploit project type of commands or anything. However, keep in mind when it comes to Metasploit here, you may be able to identify some of those any kind of Metasploit scenarios by looking at some of the Metasploit commands like your MSF console, your MSF CLI, or MSF web. If you see any of that, that would indicate that it is Metasploit. Also, if you have the ability sometimes, check out the securitytube.net website, and they have a Metasploit section there that might be pretty good to get a little bit more in depth into the Metasploit project and so forth. All right, now keep in mind we also had mentioned the OWASP, right, the Open Web Application Security Project, and so forth. And keep in mind, as we looked at the top 10, and we were able to identify a few of those, and we talked about a few of those, keep in mind it is basically providing us as users and administrators and so forth a list of flaws and also how to fix them appropriately and such. So we talked about some cross-site scripting stuff, right? And we basically looked into and said, hey, if anything pops up that has a script within it, as in the slash script and so on, then that most likely is some type of cross-site scripting scenario, right? So you should be able to identify those fairly easily as you're going through. Just take your time as you're going through those, and check that out as you're going through. Now, another thing that I didn't mention yet was the OWASP also has a web application that has a complete list of full list of known vulnerabilities, which is called WebGoat. And again, this is something that OWASP provides us to do some checking on and so forth. Obviously, with a lot of these, we want to make sure that we keep them up to date, update them as much as possible, and then kind of take it from there.